It's I think it's C double bonded O and then O and R on another side.
Okay, so I'm giving you some examples. You
Okay.
tell me
Mm-hmm.
what is their name, and also what sort of functional group in that particular organic compound. Okay,
Mm-hmm.
so let's suppose I'm giving you CS3. But, oh. And maybe there is possibility that there two or three functional group also can be present. Okay,
Mm-hmm.
great. Okay, so tell me, in the first
Mm-hmm.
group, in the first organic compound, sorry.
This one, right? This one.
Yeah.
Okay.
Mhm.
I think it's gonna be a ketone.
How?
Or it's C double bonded O, right? And then there's two alkyl groups on the other side.
Great.
Oh, okay.
Mm. So this is ketone. Then this one.
Um, you said there could be multiple, right? Functional groups in one
Yeah. Yeah.
molecule. Okay.
Mm.
Mm, then I think in this case there would be two ketones.
Yeah. So see, whenever there is two ketones, and in between these two ketones, if there is a CH2, then this group is known as anhydride.
Anhydride. Okay.
Hmm. Then this one.
That one, CHO. Hmm. Mm, CHO. This would it be would it be aldehyde? No, right? No.
Hmm?
CHO, would it be aldehyde?
Yeah. So I can also write here CHO, and one there is one more probability that is like C double bond O and H. Hmm?
Mm-hmm. Yeah,
That is aldehyde.
yeah.
And as this aldehyde on benzene, this is benzene ring, na?
Mm-hmm.
Hmm. So this is also known as benzaldehyde. Okay.
Benzaldehyde.
Yeah. Then tell me fourth one.
Mm, hold on. I think this would be, 1 second. Not carboxylic acid. It's not that. It would be, sorry. Would it be an ester?
How?
No, I think it would be an ester.
Yeah,
Oh.
that's it.
Okay, ma'am, you make me like second guess myself and then I get scared.
Yeah. Just because, to gain more confidence in yourself.
Yeah. I understand.
Hmm. Then
That's
this one.
good. Um, would it be an ether?
Yeah, you are great in this.
Thank you.
I'm just thinking that if you are not able to guess correct functional group, then like it may be causes some sort of issues when we do chemical properties. But you know functional group very well, so this is good.
Thank you.
Hmm. Now this
Um,
one.
this is C, okay, CHO.
Yeah,
I think this would also be an aldehyde, right?
yeah, yes, great. Okay, so now you tell me what sort of reagents we need in oxymercuration demercuration.
Reagents.
Mhm.
I think NaBH3?
In case of
Or
oxymercuration demercuration.
okay, sorry. MgOAC2,
Mg?
magnesium, Mg magnesium, right?
No, you
Oh,
are.
wait, no, Hg. Oh,
Yeah,
sorry, that's mercury. Sorry.
yeah.
Hg, then OAC, and then 2.
What is OAC over there?
Is it an anhydride?
No,
Oh, I don't remember that actually.
acetate. Acetate.
Acetate?
Mhm.
Acetate or acidic?
Acetate. OAC is
Oh,
acetate ion. Okay.
okay, acetate.
Yeah.
OAC is acetate. Okay.
Mm.
So mercury acetate?
Mercury diacetate, because in this case we are using two acetate, na OAC twice.
Okay.
Hmm.
Okay. Mercury diacetate, and then there's THF, right?
Hmm.
That one is tetrahydrofluoride, and then there's peroxide, right?
No.
Oh no, peroxide is in hydroboration oxidation. I think so. Then there's I think there's OH
Hmm. Only
and
OH?
hmm?
Only OH?
OH and H2O, right?
No, only H2O, then NaBH4 we
Awesome.
are using in this case. H2O and NaB. Oh, sorry, H2O and yeah, NaBH4.
Okay.
And in case of hydroboration oxidation,
Mm-hmm.
tell me, in case of hydroboration oxidation,
Uh, NaBH4 or 3? NaBH3. I think it's NaBH3 THF.
no, no,
Uh,
not NaBH. NaBH3 is a reducing agent. We doesn't need reducing agent in the starting of the reaction, no?
oh, is this, sorry, hydroboration?
What hydroboration is a process, that is a phenomena.
No, I'm asking, like,
Yeah.
I'm asking
That's the first. Yes, I got it. The first step is hydroboration.
okay.
Yeah.
Hydroboration would need, I think there would be THF and NaBH4. Or
No.
that's wrong.
Yeah.
So NaBH4 is just for oxymercuration.
Yes.
Okay. Oh, hydroboration oxidation. Is it just H2O OH and then peroxide for hydroboration?
Yeah, tell me.
Yeah, so it would be like hydroboration. It would be NaBH4T or hold on. I know there's THF for sure in that,
Yeah. So in
but
case of
there's okay.
mercuration, demercuration, we are using HgOAc twice with THF. Okay. And then
Uh-huh.
in next step, we are using H2O. And after that, we are using NaBH4. These are the reagents which we needed in oxymercuration, demercuration. After that, hydroboration oxidation. Okay. In hydroboration oxidation, we use BH3. Okay. Then THF, then H2O2, and H2O2 we are using in basic media. That's all. Okay. So how many reagents are same in oxymercuration, demercuration?
Mm, H not H2O, sorry.
No, not any,
Only THF.
only THF. Okay.
Why is that the case?
Hmm?
Why is that the case? I'm not sure if you explained how the reagents work. I think you probably did. Yeah.
Yeah.
I think you went over what the reagents do, but if you don't mind like repeating yourself, like why is it only THF that's the same? Or is that like not a relevant question at all?
No, no, this is irrelevant. The THF is this compound. Okay. This compound. This compound is known as THF and all there is hydrogen.
Mm-hmm.
Okay. So these two oxygen is having lone pair, na?
Mm-hmm.
So what HgOAc twice will do, let's suppose here is HgOAc and OAc. HgOAc is if there is a acetate ion will remove, so in that case HgOAc will again attach with this one because of bonding. So what THF will do after OAc removal, this oxygen give its lone pair to Hg. So Hg
Mm-hmm.
will stabilize and not affect the whole reaction. Same for BH3. What THF will do, it will stop the BH3 to making polymerization, because if BH3 is singly present, so it will converting into B2H6 like into a polymer. So to stop that polymerization reaction, we use THF.
Mm.
Okay.
What's wrong with the polymer form?
Sorry.
Like why can't we use the polymer form?
Because after polymerization the compound will stabilize, like B2H6 looks like this. Hydrogen is boron, boron, hydrogen, 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 and hydrogen. This is B2H6 and BH3 is like this. So in case of BH3, this boron is having vacant orbital, while in case of B2H6, there is no any vacant orbital. So, to proceed any reaction, this is more favorable as compared to this, because there is no any vacant orbital. So in which orbital we donate or gain or lose electrons. Okay, this is a stable compound. This compound doesn't give any sort of reaction.
Okay, I see. And then when you have the mercury diacetate, so how does the reaction proceed?
In case of mercury diacetate. So see, in case of mercury diacetate, this compound doesn't form a polymer. This compound, let's suppose this is the reaction Hg. Give me a second. Here is HgOAc twice. Okay. So how the reaction will proceed? So in case of the reaction, we just proceed HgOAc plus OAc minus. Okay. These two compound will form, and after that this OAc will attack, oh sorry, this HgOAc attack and attach on the double bond like this. Do you remember that reaction mechanism?
Mm-hmm.
this HGOAC, and one OAC will remove. So, see, if OAC is singly present in the whole reaction, then what it will do? It will again attached to this one and break the bond and doesn't form any sort of alcohol in the end. Why? Because after generating this compound, we are getting only this compound again. Okay. So we are not able to proceed the whole reaction at that time. So to stop that, what we will do? We just attach this OAC to THF. So this THF will stabilize this OAC, and after HgOAC, that is mercury acetate, will form and generate alcoholic compound. Now you think that how we know that is in the starting of the reaction, did we know that we need THF to proceed this reaction? So the answer is no. After doing practical, after getting product, we will decide that if we add the THF in the starting, then the reaction is more favorable. The rate of reaction will increases. Okay, so on the basis of practical data, we are going to use different solvents. THF is a solvent.
Okay. Oh, so the when you write the mechanism, right? So at the top you would have the reagents and at the bottom you would have the solvent, right? Or no, that's not how it works.
Mm, majorly in cases you're right. Like majorly in cases we write down the solvent below the arrow. But in some cases, let's suppose if I have two step in any reaction. So in that case, the first step I'll write on above the arrow, and second step I will write on below the arrow. Okay. So it not a rule to put solvent below the reaction or below the arrow.
Oh no,
Okay.
I was just asking because TH4 is a THF, I'm sorry, is a solvent. So like
Yeah.
it doesn't matter where you put it, right?
Yeah. Yeah.
Or it doesn't matter like where you put it around the arrow.
Yeah. Yeah. That doesn't matter.
Okay.
Hmm.
So the OAC attaches to THF instead of the mercury. Or no, sorry, the OAC attaches to the mercury while one of the bonds fall off from
OSC,
HGOAC plus.
OSC will attach to THF to stabilize and to increase rate of reaction.
Okay.
Okay.
Because the HDOAC plus is already unstable, right?
Mm-hmm.
Okay. So it
Okay.
needs a stable molecule at THF. Okay.
Okay. So now we will start with chemical properties. What is chemical properties?
Mm, like the properties of a compound, like it could be boiling point, it could be like, like solubility,
Is that is chemical properties?
optical. Oh, those are physical properties, sorry. No. Chemical properties. Um, does it have to do with like the subatomic?
Sorry, subatomic means?
Like the, because like boiling point, right? Or like those types of things are physical, right?
Yeah.
Density, boiling point, all of the temperature,
Mm-hmm. All of
those
these
are
are,
all physical.
yeah. So what is chemical properties? See, chemical properties are those properties. Let's suppose, let's talk about melting point or no, no, let's talk about only temperature. Let's suppose. Now let's suppose I'm taking H2O. Okay, H2O which is in solid form. That means I'm taking ice. Okay, now I heat up that H2O like water and give the water temperature up to 100 degrees Celsius. So in that case, what will happen? Hmm?
Mm, 100, that's gonna boil, right?
Yeah, that's going to boil. It converting into vapors. So after giving some temperature, the water is converting into vapors. And let's suppose if I'm not giving 100 degree, I'm giving it like 10 to 20 degree temperature. So in that case, it start to melt. Yes or no?
Mm-hmm.
Ice starts to melt and it
Mm-hmm.
converts into H2O. Okay. So H2O firstly is in the solid form, and after giving some temperature, H2O is in liquid form. But is the composition of H2O will change?
No.
No. What is the composition of H2O over solid and in liquid form? Hmm? What is
Solid and liquid?
yeah
I mean, it's
composition?
still water.
Hmm?
It's still water, H2O, right?
Yeah, H2O. That is the composition of water. So in that case, the composition not changed. So physical properties is those type of properties which doesn't change any chemical composition of any sort of organic compound. Okay, while in
Mm-hmm.
case of chemical properties change their composition. Okay,
Mm-hmm.
let's suppose if I'm using uh let's suppose I'm using any sort of dye, hair dye or any color. Okay, and I'm using water as solvent. Okay, so if I'm putting any color into water, so the water's color will changes. Yes or no?
Mm-hmm. Mm-hmm.
Why that will change?
Mm, because the dye, there's a pigment.
Yeah, and how pigment will work?
I think it has to do with the chemical property
Hmm, how that will work?
of a pigment.
Yeah.
I don't really, I don't know the
Okay.
that much detail about pigments.
Okay, let's suppose I have this H2O. Okay, and there is any sort of pigments I'm using in the starting of this reaction. Okay, and so how they will work? The pigment attached with this lone pair of oxygen, and this will converting into this one, and the pigment attached to here. So see, we are having some sort of clothes. Then that if like if I wash them at home with water, so in that case they lose their color.
Mm-hmm.
Yeah, and some sort of clothes we are having that doesn't lose their color. They are like actually whatever they are. So in that case, if they lose their color, that means some sort of pigmented or some sort of product will again converting into the water form. Okay, they lose
Mm-hmm.
this bond. That's why they are decolorized. Okay,
Mm-hmm.
and some sort of like as it is. So in that case, the color generated by the addition of that bond. So, see, is there any chemical composition change throughout the reaction of water? Like water's chemical composition change or not?
If that pigment is added, yeah, right?
Yeah, yeah, yeah. So, is this a chemical property of alcohol or a physical property?
Chemical property.
That's great. So, that's how we identify chemical properties. Okay.
Oh, it's like how people used to make like, indigo and stuff like that,
Yeah, yeah. So,
dyes
in
and stuff.
uh, there is a topic same as alcohol, that is phenol. So in case of phenol is used to form indigo and the green color and the yellow color, orange color.
Mm-hmm.
So in majorly cases, phenol is used to
Mm-hmm.
form dyes. Okay, because phenol give very stabilized compound after pigment form. Okay, so we'll start with the chemical properties of alcohol. So in this case, there is two types of chemical properties of alcohol. What is the chemical formula of alcohol? ROH.
Mm-hmm.
Is that right?
Mm-hmm.
Okay. So in this case, we discuss two types of chemical properties of alcohol. Okay. The first type of when the O and H bond will break. Okay. And the second
Mm-hmm.
type is when the R and O H, basically this bond will break. Okay.
Mm-hmm.
So there is these two types of chemical properties of alcohol. First is when the bond in between oxygen and hydrogen will break, and another is R and oxygen will break. Okay. So can we
Mm-hmm.
start with the first one?
Mm-hmm.
You can start from noting down from here. Okay.
Yeah, give me 1 second.
Yeah.
I just have to pull out my pencil.
Great.
Mm.
Okay. So in this case, the first reaction is to check acidity of alcohol.
Mm-hmm.
Now the term acidity comes. What is acidity?
Aren't there like three different definitions?
Great.
So, is there like a Lewis? Hold on, forgetting.
Yeah, yeah, you can take your time.
I learned this in general chemistry and even in high school. Let me try to recall. There's a Lewis acid.
Yeah,
Um, then there's like another Arrhenius
yeah.
and Lewis Arrhenius, and then I'm forgetting the third one, the name of it.
Bronsted.
Oh, Bronson Lowry, right?
Mm-hmm.
And now I remember. Okay, yeah, so those three.
Yeah. So, according to Lewis is by lone pair. Okay, Arrhenius. Let's talk about Arrhenius. What is Arrhenius acid?
Mm, okay. I think I'm gonna get these mixed up because I don't remember like really 100% clearly, but I remember one has to do with
Mm-hmm.
donating H plus and accepting H plus.
Yeah, that is Bronsted.
Bronsted, okay. And then one is like donating electrons, accepting electrons, right?
Yeah, that is Lewis. So acid is donating electron or gaining electron.
Donating.
Acids.
Mm, yeah, acid. And base would be gaining an electron.
Mm, great.
One of them also has to do with the pH scale, right?
Yeah, that is Arrhenius on the basis of uh, H plus and OH minus.
Okay.
Mm. So, if we needed to check acidity of alcohol,
Mm-hmm.
so we used there is alcohol. As we are discussing the bond breaking in between oxygen and hydrogen.
Mm-hmm.
So, as the bond of OH will break easily, in that case, that will be more acidic. Yes
Mm-hmm.
or no?
Mm-hmm.
Let's suppose I have a compound that is A, O, and H. Okay. Then I am having B, O, and H. Okay.
Mm-hmm.
So A is more electron withdrawing as compared to B.
Mm-hmm.
Okay. So tell me in between AOH and BOH, which is more acidic?
Mm, wait, sorry. Between AOH and BOH?
Yeah.
What did you write in E double? What is that?
That is electron withdrawing group.
Electron what?
Electron withdrawing means there is two types of group na, electron donating and one is electron withdrawing.
Mm-hmm.
Plus I and minus I. Do you know them? Plus I and minus I. Hmm?
Yeah. Yeah, you mean in math? I know it's for not in math. With like a group. No, I sorry, I couldn't understand like what you wrote. I was just clarifying like what you wrote in the when you anyways. Electron withdrawing group. So if A can withdraw electrons better,
Mm-hmm.
then that means withdraw electron. Then that means it would be an acid, right? Or more acidic. Wait, ethylene withdrawing. Yeah, because it's electron withdrawing, not electron gaining.
Yeah. So which is
So if it hmm?
like in case of AOH and BOH, which compound donates hydrogen easily?
A.
Like after breaking of this bond, the oxygen is getting negative charge in both the cases. Yes or no?
Mm-hmm. Mm-hmm.
So this negative charge is stabilized by electron withdrawing group or electron donating group.
Mm,
Let's suppose
withdrawing.
that withdrawing absolutely. If there is a donating group present, so the group also donates, and the oxygen is also having a negative charge, means it also has extra electrons. So if
Mm-hmm.
electron donating group is present over here, then the acidity of alcohol will decreases, while in case of electron withdrawing group, the acidity is increases. Okay.
Mm-hmm.
Okay, so that's how we check acidity of alcohol. Now let's suppose I'm giving you some. Okay, so I'm giving you some sort of uh, acidity. Like how we can check acidity of alcohol. There is a reaction to check acidity of alcohol. Okay, so if
Mm-hmm.
I use CH3OH and I proceed this reaction with sodium, so in that case, what will happen? Hmm? So in this case, CH3O Na will attached over here, okay, and there is H2 will removed out. This is the reaction.
Mm-hmm.
This is the general reaction to check acidity of alcohol.
Mm-hmm.
Okay, general reaction. So let's suppose this is Na. Okay, what is the valency of Na? Na is what sort of element? Is it sodium, magnesium,
Sodium.
sodium? Great. So what is the valency of sodium?
2.
Think again.
Wait, sodium. Is it 3?
How you
Oh
check
man.
valence?
Oh. No, no, no. I learned about this a long time ago, only in school or something. What is it? Na? It's on the periodic table, sorry.
Yeah. So how many outermost electrons Na have? Outermost electrons.
Let me check.
Yeah.
Because we don't memorize the periodic table in
Mhm.
America, so I know it's a little like annoying and frustrating that I don't know like these things. Okay, wait. In the first row, oh, Na plus, right?
Yeah. So
Na
Na
plus, sorry.
plus
Mm-hmm.
Na plus 1. So what is the
Mm-hmm.
valency of Na here? That is 1. Hmm?
Mm-hmm.
So Na plus 1.
Mm-hmm.
And let's suppose I'm breaking this bond. Hmm?
Mm-hmm.
Hydrogen is also plus 1. And oxygen is?
Minus
Hmm.
1.
Yeah. So after breaking this bond, the Na plus attached to oxygen minus and the gas H2 will remove out. Okay.
Mm-hmm.
And now I'm using, this is the reaction. This is a reaction to identify that the alcohol is acidic or not. Okay.
Mm-hmm.
This compound is known as sodium alkoxide. Sodium alkoxide. Okay.
Mm-hmm.
Hmm. So this is a reaction to identify that the alcohol is acidic or not. Then after that, I have one more reaction. Let's suppose that is CS3OH. Again, I'm using. But now in this case, I'm not using sodium. Instead of sodium, I'm using magnesium. Okay, let's suppose I'm not using magnesium. I'm using here aluminium. If I'm using aluminium over here, so what will be the product in that case? Now you tell me.
Hmm, aluminum, aluminium. Let's see. Oh, that is gonna be +3.
Yeah.
So it has a valency of 3.
So how the product will form? So CS3O, there is price of this one and aluminium, then H2 will remain. Do you understand how?
Mm, yeah, so the bond breaks between oxygen and hydrogen, right?
Yeah. And this is minus and this is positive, while
Mm-hmm.
aluminium is having +3. So after cross multiplication, the 3 comes under CS3O. Okay,
Mm-hmm.
great. So these are the two reactions to identify that the alcohol is acidic or like acidity of alcohol presence or not.
Mm-hmm.
Okay, this is the first reaction. Then
Mm-hmm.
after the second reaction is esterification. Esterification. A we discussed, now we are B. Esterification is most important reaction. Esterification. Okay. So first you tell me what is ester.
Ester is
Hmm.
it's like when you have R and then O double bond R double bonded O and then O.
O only. Let's suppose I'm having CH3OH. CH3OH. So what the sort of functional group in this case? Hmm?
CH3OH, that would be aldehyde, right? Or actually no, because there's no double bond. Sorry. Al it would be alcohol
Yeah.
or hydroxyl. Yeah.
And in the second one?
Mm, I think that would be ester.
No.
I just gave you the answer when you asked me in the beginning of class. I don't know what happened to me. Wait. Oh, carboxylic acid.
Yeah, that is
Okay.
carboxylic acid. So, uh, when alcohol and carboxylic acid comes together,
Mhm.
they will give you ester. So, what is ester? Tell me.
What is ester?
Yeah.
Mm, hold on. Esterification? What is ester? So it would be R C double bonded O plus O, right?
Mhm. Es- Ester is RC double bond O, and one is O, and there is
Mm.
R attached to C double bond O group. Okay.
Yeah, that's I got that.
Okay.
Yeah.
Now, there is a mechanism. There is a whole mechanism that how we can form esterification. Okay.
Mm-hmm.
Okay. So we will start with that mechanism now. Let's suppose I have Okay, so we are starting with here only. Let's suppose this is alcohol we are having.
Mm-hmm.
Alcohol. And here is carboxylic acid. Carboxylic acid. Okay. Now there is a lone pair on carboxylic acid. Tell me how many lone pair carboxylic acid have.
How many lone pairs? Total one, two, three, four.
Oh, absolutely. And alcohol?
Two.
Two. So let's suppose we start with acidic medium. Okay. There
Mm-hmm.
is two types of mechanism in case of esterification. The first is acidic medium, and another that is like in the presence of basic medium. Okay, so we only need to learn one mechanism. Okay, so we start with acidic medium. Let's suppose if we are having acidic medium, in that case, how the reaction will proceed. Okay, so if we are using acidic medium, so this lone pair attack to this hydrogen. Now in this case, hydrogen is work as nucleophile or electrophile. Tell me.
Mm, that would act as a nucleophile.
Hydrogen.
Oh, hydrogen electrophile.
Yeah, and CH3OH.
Nucleophile.
Yeah, it's nucleophile. So after that, it will convert into CH3O, hydrogen, and hydrogen. And this oxygen is having lone pair. Oh, sorry, this oxygen will getting positive charge. Why positive charge? Just because of a extra bond. Okay.
Mm-hmm.
Then this react with carboxylic acid. Okay. Carboxylic acid, this carboxylic acid. And now this carboxylic acid having lone pair. Yes or no?
Mm-hmm.
So now this I can write over here. Okay. So this is having lone pair. Now this lone pair attacked to this CH3O and H. Why on this one? What is the reason behind that? Hmm?
Mm, wait. What? Sorry, can you repeat the question again?
Okay. See, we are going with esterification mechanism. Okay.
Mm-hmm.
Esterification. What is meaning of esterification? Esterification means formation of ester.
Mm-hmm.
Okay. Formation of ester we need to do with what? With alcohol and carboxylic acid. That is two reagents or reactants we are using in this whole reaction. Okay. So
Mm-hmm.
after that, there is two possibility to like complete this esterification process. So the first is in acidic medium, and there is another method also that is in basic medium. Okay. So we are starting with acidic medium part. Any doubt up to now? Like why we
No.
are using H positive here? Why alcohol? Why carboxylic acid? Any doubt?
No.
No. We are generating ester with the help of alcohol and carboxylic acid in the acidic medium. So in case of acidic medium, we need a H positive. Done.
Mm-hmm.
Now what is the next process? So in that case, the alcohol, whenever alcohol is in acidic medium, it will converting into a sort of electrophile. Why it needs that? Like,
Mm-hmm.
see, there is alcohol and carboxylic acid in a test tube, let's suppose. And now I'm putting acidic medium means hydrogen ions into that test tube. Now there's two possibility that alcohol can attach with H positive or carboxylic acid also can attach with H positive. Then why alcohol attach H positive firstly? Why not carboxylic acid? Think about this. Hmm?
Mm, because the alcohol has less lone pairs overall, so it can attack, and then it creates an sp3. What's it called? The oxygen is sp3, right? So that is probably more stable, right? Because it would be trigonal planar. The
Mm,
intermediate?
no, your
No,
approach,
sorry.
yeah, yeah, your approach is a little bit like into correct side. But see, the major reason, let's suppose you are telling me that alcohol is having least least lone pairs.
Mm-hmm.
You are telling me that alcohol is having least lone pair. That's why it attack on H positive. But the main reason is that let's suppose I needs to go into a war. Okay, I'm going into a war, and you are also coming from the opposite direction. You are having four trucks, like the four trucks which are loaded, and I am having only one, or let's suppose two.
Mm-hmm.
So, according to you, which is going to win the war?
Mm, one like the one that sorry,
And
you
four?
sorry, I'm sorry for making you repeat. More lone pairs, right? I was thinking it can donate more to the intermediate.
Yeah. So see, this lone pair, there is lone pair over here, okay, and this is
Mm-hmm.
carboxylic acid. In this case, this carbon, okay, there is one carbon, and this here is this carbon, okay. So this carbon is electropositive or negative? Like this carbon
Electropositive.
have, yeah, so this carbon needs electron more as compared to this one. So what the process will happen here, the lone pair will comes to this carbon
Mm-hmm.
and like this, okay. So
Mm-hmm.
these lone pairs of oxygen are used in resonance.
Resonance, I was about to say that.
Yeah, so these lone
Mm-hmm.
pairs are coming into resonance, so they are not free as compared to
Mm-hmm.
alcohol. Okay, so now
Mm-hmm.
alcohol will attack to the H positive and converting into hydronium ion. Okay, this is a hydronium ion. Now, now as we know that now there is not any sort of lone pair having this oxygen. Yes or no?
Mm-hmm.
Yeah.
Mm-hmm.
So after this, the lone pair of carboxylic acid coming and they will attack to the oxygen over here. Done. Hmm? Now this
Yeah.
carboxylic acid are going to attack on the oxygen. Okay. So this is the first step. Then after attacking of this bond will break. Yes or no?
Mm-hmm.
Because how many number of bonds can oxygen form? Like the maximum number of bonds. Hmm?
Mm, how
How?
many? No, the maximum four, right?
No?
No, no, sorry. Oh, to something else. Oh
Yeah.
yeah, two.
Only two. In this case, only the oxygen is forming three bonds now.
Oh, three bonds.
In case of
Wait,
yeah,
that's not stable though, right?
yeah, that's not stable.
Oh,
But I'm
okay.
no, no, I'm asking that it can be stable or it cannot be. But like how many maximum number of bonds oxygen can form? That's the thing.
Well, if it forms three, there would be one lone pair,
Yeah,
right? And that would be positive.
yeah, yeah. So three maximum bond can be formed by the oxygen. So let's suppose if the lone pair of carboxylic acid
Mm-hmm.
attack on the oxygen which is positively charged, so that alcohol, that is protonated alcohol, needs to donate the hydrogen now.
Mm-hmm.
Yes or no?
Mm-hmm.
Yeah. So that's why the bond in between oxygen and hydrogen will break. And then the compound or the adduct which we are gaining, that is CH3 over here, C, oh sorry, O, okay, and hydrogen, and this one oxygen, carbon, OH, and R. Any doubt up to now? Hmm?
No.
Is the structure is right or not?
Mm, I wait. There's one lone pair on the first on this oxygen. And then wait, sorry, I hold on, I need to zoom out. And then the second oxygen has two lone pairs. That one's more stable. And the third oxygen on the at the bottom on the right has two lone pairs. So the most unstable one is the top one. Is that what you were asking, or
Now I'm asking you that is there like the structure is correct or not? This
no?
oxygen will get
I think
positive.
it is. I think it is.
Hmm?
Oh. Mm, mm, the lone pair. So for the oxygen that's in gold, right? The one of its lone pairs is donated, right?
Yeah.
So then there's another bond. So there's three bonds total. Okay, yeah. So that should be positive. Top one should be positive. I think you're correct. Yeah, I think you're correct.
Okay. So there is two oxygen and oxygen and they are forming bond and they both of them are having positive charge. So is there any possibility to stabilize these compound?
Their charges are gonna repel, right?
Yeah. So the
To
bond will,
stabilize them?
yeah. If the charge, if they are having same
Mm,
charge, so how they will stabilize?
mm, shifting the lone pairs?
Where is the lone pair? This bond will break immediately.
Oh, okay, because it's that unstable.
Yeah.
Yeah, it would
This
break.
bond will break immediately, and the hydrogen, which is like here donates, this O will getting that hydrogen. Okay.
Yeah.
So after that, the compound will form that is RC double bond O OH, and here is hydrogen now. Then again positive charge because oxygen is having three bonds. Okay.
Mm-hmm.
Any doubt? This bond will break, and this is the structure which I am generating here. Okay.
Yeah.
Yeah. Now this is CH3OH. Okay. The CH3OH attack on the carbon, and that bond will shift. How? See. Yeah. So now we are taking a CH3OH molecules in the next step. CH3OH. The lone pair attack on this carbon. Okay. And after attacking this carbon, see the carbon is having four bonds over here. Yes or no?
Mm-hmm.
This carbon.
Mm-hmm.
What is the hybridization of a carbon which is in carbonyl position?
SP3?
Are you sure?
SP2, sorry, SP2.
Yeah, sp2. So after attacking this, the carbon is fully like it completed its bond. It doesn't form a more bond like five bond. So what will happen? The bond shifts to oxygen. Okay, yes or no?
Mm-hmm.
Because oxygen up to now oxygen is having only two bonds. Or
Mm-hmm.
sorry, oxygen is having three bond but with a positive charge. So after shifting electrons, the positive charge will remove and the product is like RCO H, O, H, and here is O, H, there is CH3 will come. Any doubt up to now? Anything? And there is a positive charge on this one.
No.
Sure.
Yeah.
Then in next step. See, this is after that we will proceed with the deprotonation step. Okay. In case of deprotonation step, this hydrogen will remove. Okay. Why
Mm-hmm.
only this hydrogen? Why not these two?
Mm, those are not removed. Is it because let's see.
Hmm? See,
Sorry, I'm trying to think.
you can think. See,
Mm-hmm.
in this case, oxygen attached to hydrogen, but oxygen is stable. It has
Mm-hmm.
two bonds. But in this case, the oxygen is having three bonds. Yes or no?
Mm-hmm.
So the bond which is this one, it going to break, okay, and it will converting into RCOH, OH, and O with CH3. Okay.
Mm-hmm.
Any doubt? Then the major step come. See, which you needs to know that at any carbonyl carbon, anything, okay, there is, if there is two OH bond means two hydroxyl groups. If there is two hydroxyl group on the same carbon will present, so in that case they are highly unstable.
Mm.
Highly unstable. Why?
Is it because of like some sort of interaction like between these two groups?
Yeah, each oxygen is having how many lone pairs?
Two.
Two. So these two lone pairs in each case will repel each other. See?
Mm-hmm.
Okay. So due to this repulsion, both of them are unstable. Now in this case, we are having a lone pair on this oxygen also. So what will happen if there is two OH group present on any carbon? So in that case, a mechanism will happen always. You need to remember that mechanism. The hydrogen shifts to here and this OH bond will break down. Okay, so it will converting into, are you able to identify what I'm just doing?
Mm-hmm.
Hmm? Sure.
Mm-hmm.
Let's give me a second. Okay. Laptop is not good. Okay. Yeah. So now what will happen? See, this hydrogen will shifts over here and the OH bond will remove. So OH and one hydrogen over here. So H2O will remove. Dehydration will take place. Okay. And after dehydration, the compound which is formed, that is R C double bond O and O CH3. What is the functional group here?
Mm, R RC double. That would be this should be ester, right?
Yeah. If I'm using hydrogen instead of methyl group, so in that case, what will be here? Like what sort of functional group over here? If I'm replace this CS3
Mm.
group with hydrogen.
If you took away the CH3
Yeah.
and then put in hydrogen,
Yes.
that would be carboxylic acid, right?
Yeah. Great. Okay. So this is the mechanism of esterification. Let's start with again. Okay, with this mechanism. What is esterification?
Mm, you're basically trying to prepare an ester.
Yeah. We are preparing ester. Ester with what sort of functional group we are going to prepare?
Alcohol and carboxylic acid.
Alcohol and carboxylic acid. Okay. And this esterification method proceed in what medium? In what sort of mediums?
Soluble?
No, no, I'm asking about medium. Medium means the medium is acidic or basic.
Oh, acidic.
Acidic. Great. So in acidic medium, there is H positive. Why carboxylic acid not attack on electrophile while only alcohol attack on electrophile?
Hmm, because carboxylic acid has more lone pairs which it can donate to the unstable intermediate. Oh, and also it does more resonance in general, so it's just more like stable. It
Yeah,
yeah, it
that
is
is
able
more
to
stable.
contribute.
Mhm. So alcohol attack on H positive. Okay, great. Then it is converting into electrophile or nucleophile. Hmm?
Mm, what's converting?
Alcohol converting into electrophile or nucleophile after add H positive.
Mm, electrophile?
Yeah. So after this, the carboxylic acid attack on which side? Hmm?
Oh, it attracts the central carbon. I'm sorry, oxygen.
Yeah. So you can skip that part and okay. So you can directly skip that, like you can skip that part and directly go with this step. Okay. Skip this part because this is a little bit more complicated. See, after this carboxylic acid, gain this hydrogen. Okay. Why? Because this is the extra hydrogen on alcohol. Okay. So this working as nucleophile and have this hydrogen over here. Okay. So see, now carboxylic acid, the oxygen of carboxylic acid gaining this one. Yes or no?
Mm-hmm. Mm-hmm.
Okay. After this, the alcohol again attack on
The
are you?
alcohol
Hmm.
the alcohol attacks on the carbon, right?
Yeah. Then
In yellow. So then the electrons get shifted
hmm.
to the oxygen,
Yeah.
which it makes it more stable, but then the oxygen that donated like the alcohol, that one it becomes part of the structure, like but it's like less stable.
Hmm. Yeah. Okay. So you understood this the mechanism. Do you noted this mechanism?
Mm, yeah, and then at the end the hydrogen bond comes off because it's so unstable, right?
Yeah.
The positive.
Okay. So let's start this mechanism again, and now this time you will tell me what is the mechanism. Okay. Firstly, tell me what I need in the starting part. Hmm?
Can I look at my notes or no?
Sorry?
I can't look at my notes, right?
Yeah, yeah, you can.
I can?
Yeah.
Okay, yeah, so first we have basically like this reaction is gonna be to prepare ester and we would need to do it in an acidic medium. And so we
Yeah.
would need to use the two reactants, alcohol and then carboxylic acid.
Great. So I'm using
So
alcohol over here, but this time using different alcohol.
okay.
This is alcohol. Okay. And
Mm-hmm.
and I need one acid. Is these are right or not?
Mm-hmm.
Okay. Now what we need?
Now what you need, so basically what's gonna happen is when the reaction takes place in the acidic medium, you're gonna have a loss of hydrogen, right?
Huh?
Is it a loss of hydrogen or addition?
How? How loss of hydrogen? This is the first step of reaction. Why we need to lose any hydrogen?
Oh, okay, okay, sorry. Uh, I think I misunderstood like when you were doing the reaction that it like loses or something. That's not okay, that's not right. Um, oh, sorry, yeah. So anyways, in the first step, so when so you don't add a hydrogen, like that's just or do you add a I don't know, like
What is the
yeah, I
next
guess
step?
you add.
Going to tell me that now
Uh-huh.
alcohol will attack on H positive or carboxylic acid? You
Mm,
you close your notes
alcohol.
and think about this, okay? Because if you are like searching in notes, then it is a little bit complicated. Alcohol will attack, okay? So
Mm-hmm.
alcohol will attack on H positive.
Mm-hmm.
Then it will converting into CH3, CH2, CH2, O,
Like
and
intermediate structure?
this is not an intermediate. This
Like an
is a
adduct or something?
transition state, we can say. Okay, transition state, we can say, or adduct, we can say.
Adduct, yeah.
Then what will be the next step after
So basically what's gonna happen now is you're gonna have the carboxylic acid, it's going to
hmm?
bond with the what like the transition state molecule. And then when it does and it's better
Oxygen
able
will
to do
attack.
the I'm sorry?
Which oxygen will attack?
The one with the lone pairs that's double bonded to the
Okay.
carbon.
Okay. And what
Yeah.
is going to like what is the next step after
Mm-hmm.
this?
Yeah, so basically,
Hmm.
or I guess I don't know if it's important. I guess like I could also add that it bonds to the intermediate structure because it's better able to like it's more stable, it can do more resonance, whatever. So after it bonds, then you're gonna have a structure where the double bonded oxygen, like that oxygen that connects to the carbon, that one will
Take this
basically
hydrogen.
huh?
Take this hydrogen from alcohol.
Yeah, no, I think it'll bond with the oxygen. That oxygen
We
will
can
bond
skip
to the
that part. We can skip that part. You
oh.
can erase that part. Okay, because that is increasing only the steps. Okay, you doesn't need that. Then
Oh,
after
okay. I mean, I understood it regardless. So then you
Mhm.
have CH3. Um, oh, you're
CH3.
right. It's a bit complicated. CH3 and then CH2 and then C
Now
double
you see.
bonded. C.
You doesn't need to check your notes now. Now you are applying your concept. So why this hydrogen going to the carbonyl part now? Tell me that one. Like why
Oh,
this hydrogen going to
I'm not
uh-huh.
really looking at my notes. I'm trying to like go,
Okay,
I'm
okay,
just
wait,
getting
wait.
some idea.
Yeah, yeah.
Okay. Can you repeat your question?
Now this hydrogen is going to the carbonyl part of
Mm-hmm.
all na? So why the
Mm-hmm.
hydrogen is shifted to the carbonyl part?
The hydrogen is shifted to the carbonyl part, um, because sorry, wait. It forms
Hmm?
so that like the hydrogen is shifted because it's the lone pairs that are attracting it?
Yeah.
Mm-hmm. So then
Okay.
after the lone pair is attracted and attracts it and it's bonded to the oxygen, it's gonna add, that's what I was gonna say later on, like
Yeah.
it's unstable, it's positive because there's three bonds, one lone pair. That's a very unstable conformation for oxygen. And
Mhm.
then yeah, and so that oxygen, I think one of like something happens to, like I think one of the bonds comes off.
Mhm. Okay. So due to like stability or instability,
Mm-hmm.
that will attach. Okay. After that, what will be the next part? Hmm?
And next and the last part, there's
This
gonna be loss of hydrogen.
no. Now the alcohol will attack now. Alcohol will attack on this part. And then this bond shifts to here.
Oh.
Okay. So after that, compound is CH3, CH2, C, O, H, O, H. And here is O, H, CH2, CH2, and CH3. Okay. Now this is positive part. Now what will be the next step?
Mm,
This
hmm.
H positive will remove
Yeah,
deprotonation.
sorry. That was I don't know, I forgot the step before this. Yeah, I think I was talking about this one, but it's like comes last, right? So I forgot that it comes last.
Then after this,
Okay. Wait, there's one more step?
yeah.
I thought this was the last one.
After that, see there is two OH on the same carbon. So H2O will remove.
Mm-hmm.
Okay, like this. So CH3, CH2, C double bond O, O, CH2, CH2, and CH3. Okay.
I actually don't have the last part where you take out water from the
See,
other example.
see here.
Oh. Oh, okay. Sorry, I did not write that down, I think, carefully. Okay. But I was right about the bond coming off of oxygen because it's unstable, but then you have, yeah, but then you
Okay.
have these other steps.
Hmm. Now we are writing the steps. Okay. How many steps are there? Okay. So let's start this one. For the first step. What is the first step here?
Um, the the carboxylic acid,
Carboxylic acid.
it bond with the in transition state, right?
So the first step is generation of electrophile.
Mm-hmm.
Isn't it?
Huh?
Is this right? Generation of electrophile. Hmm?
I I think so.
Then the next step is attack of nucleophile.
Mm-hmm.
Yeah. Here is the this is the first step. Okay, this whole is the first step over here. Then this is the second step. And after this is the third step. What is the third step? Deprotonation, can I say?
Mm-hmm.
Deprotonation. Then after deprotonation, the fourth step is dehydration. Dehydration. Okay. So these are the four steps in esterification reaction if the reaction is proceed in acidic medium. Any doubt up to now? Anything? Uh,
I
yeah, we are discussed chemical reactions in which the bond in between oxygen and hydrogen will break. Okay.
Mhm.
Now from next class we will start the bond in between carbon and oxygen. See, this is the compound here. This is the alcohol CH2.
Mhm.
O and H. So up to now we are discussing the bond in between oxygen and hydrogen will break. So what will happen? From next class we will start with this bond. Okay, if the bond in between carbon and oxygen will break, so what sort of reaction we are going to see? Okay, any doubt? You are going to read this reaction like at least for 4 to 5 times. So after that you are getting something in your mind and something in your memory. Okay, because this is a little bit larger reaction and you need that at which step what sort of compound will come, why that compound attack on that particular position only, why not on that position. That sort of questions you need to ask by yourself, and if you are having any sort of doubt then you can clear me in next class. Okay.
Wait. Sorry. I think I'm losing track of the steps because the I'm like trying to follow like with the other example that you showed, and I think it's different.
Why? Which steps?
Uh, like, can you label these steps again just so I can see?
Okay. Okay, so from here to the here, there is the only first step. That is attack, oh sorry, generation of electrophile. Then from here, attack of nucleophile. This is deprotonation and this is dehydration. Fourth step. Hmm?
Yeah, sorry. I'm just making sure I have the right things copied down. Like I'm just double checking because I
Okay.
don't want to just go away with like the wrong information. Wait, sorry. Can you go down again, please? Like to the not to the very recent
Okay,
one, like
okay,
the
okay.
yeah. Not this one, like the one before this one. Hold on. Uh, loss of hydrogen. Okay, loss of hydrogen is step 3, and then water. Okay, water step. Taking out water step 4. Um. Okay. Think I have it. So step 1 is generation of what is it? Sorry, generation of
Electrophile.
electrophile. Okay. And then number 2 is attack of nucleophile. And then number 3 is deprotonation. And number 4 is dehydration.
Yeah.
So when you do the I have a question. So when you do the dehydration, is
Mhm.
it so that you can get so you can get the hydrogen off of the
But yeah, the hydrogen offs and also we needs to generate ester now. That's why.
Yeah, so if you take the hydrogen off, then yeah, you can also form the ester, right? That's part
Yeah.
of it, forming ester, yeah. So the hydrogen bond comes off
Mhm.
from like one bond, like so one of the oxygen, like the or alcohol or the hydroxyl groups, like one of the hydrogen comes off, or no? No. It doesn't come off. It attaches to like what is how do you explain that? Like what's like a bond is breaking, like this oxygen hydrogen's breaking?
Yeah, the hydrogen bonds shifts to the carbon and oxygen and it generating carbonyl group now. The bond shifts, then hydrogen remaining in the compound while the hydrogen and one OH group will removed out now.
Um, yeah, I think like I don't know if I have like the terminology. I don't even know if I'm clear on any of the terminology, like breaking versus making bond versus shifting bond. Like it's I don't know.
In this case, the bond is breaking only because the
Mhm.
hydrogen is removed out from the molecule. If the hydrogen is in the compound, then it is shifting of bond. But if the element is removed out from the compound, then it is breaking the bond. Okay.
Wait, so is it where like I outlined, or like what are you looking at this one too?
Yeah.
Or like
So this is the whole thing now. This whole thing is happened together.
no, I know, I understand. That's not, I don't think you understand what I'm trying to say. Like what I'm trying to say is like this hydrogen gets shifted into this carbon, right? Or
How?
like as this hydrogen is being shifted, this oxygen is also losing the hydrogen here.
The hydrogen is shifted towards the OH group. Then it will
Yeah.
form a H2 molecule. So this hydrogen and an OH will form a H2 molecule.
Okay, that's much more clear to me now. So that part forms H2O. Oh. Oh, okay, because they fall off anyways. Okay. Okay, that makes more sense. Um, Also like so there are certain steps that you said are not really important for me to know.
Yeah, that is not important.
Which steps again?
Where the cross marks are
Oh,
presented.
here, right here, and only these two I don't need to know.
Yeah.
Oh, okay. It's just directly like after the intermediate
We can
bonds
directly.
with the
Yeah.
yeah. So, like all I need to show is like the intermediate bonding with the nucleophile,
Yeah.
right? And then like the bond splitting because of the repel, like the charges repelling each other, the positive positive,
You
the
don't
bond
need
splits,
to
right?
represent. You doesn't need to represent any step like any these type of steps in the mechanism. Because if you know, you doesn't need to represent all the things now. This is just for your convenience. This is just for you that you understand more better. Okay. But if we are writing some mechanism in the in the like notebook, so in that case we are not adding these types of step or these type of path where the mechanism doesn't go. Okay. Or doesn't stabilize anything. That's why.
Okay, I think I like maybe I'm misinterpreting like what you wrote or something. I don't know. Like,
You doesn't need, you can erase that part. Okay. That is more helpful.
okay.
Yeah. Anything else? Any?
No, I was like a little confused about the arrows, like where you were drawing. So I didn't know if that was an important step, like what I, just talked about. So like that's why like I was just asking if, I need
Mm.
like
Uh-huh.
if I need to know that. So this is like all of what I need to know, like 100%, right?
Yeah.
Okay. I think I might just take a picture just so that I don't like lose track,
You can take.
because there's a lot of different steps involved.
Yeah.
So I have to make sure I know which one like to focus on. Let's see. What happened to my
Done?
phone? No, 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 sorry, man. No, 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 my phone. I still need to open my phone or my like camera. I'm just having some issue. Okay. I'll let you know when I've taken it. Okay.
Do
Oh,
you want?
yeah, I definitely need the second example.
Yeah.
Thank you.
Okay.
Is that all for today? So what did we mainly just covered functional groups and ester, right? That's all.
Yeah. Acidification.
Esterification. Okay. So
Okay.
any homework for me or no?
For today, no.
Oh. But I think it would be helpful for me to revisit the other reactions that we talked about. Like
Okay, so
with
you
alcohol, remember?
you can go for uh, chlorides, about phosphorus chloride compounds, the compounds which is formed during the if phosphorus and chlorine are there.
Phosphorus chlorine compounds.
Hmm?
Okay. Huh?
No,
Did you
no.
say something? Oh no, I was also asking, I was also gonna like ask if I should, because I did have kind of a hard time remembering the reagents for the reactions, like the alcohol
Hmm?
preparation of alcohol. I think I should probably go back to those, right?
Sorry?
Is it methods of preparation, like when we talked about hydration, oxydemercuration, hydroboration, that's all under alcohol, right?
Yeah, all the things
Okay.
are, yeah, all the things are under alcohol.
Okay.
Maybe tomorrow is our last class. Maybe is our last class for alcohol because there
For
is like,
alcohol.
yeah,
Okay. So, do you recommend me, like, do you have any sort of feedback, or do you recommend, like, based on, because, when you have asked me about these different reactions, like anything that I should, like, try to, like, revise again, or like should I try to memorize the reagents?
for today only you needed to learn esterification, like each step in
Okay.
esterification.
Yeah, like outside of that, I remember you told me, like, you would test
Phosphorus
me again.
chloride compounds, but I don't think so that that is useful for that for tomorrow's class, because tomorrow's class is a little bit easier. It doesn't need much about like to prepare before that class. Okay.
No, no, no. I know. I'm not talking about the next class. I'm just saying, remember how you keep asking me questions about like the methods of preparation? Remember, like,
Yeah. Uh-huh.
yeah. So should I like revise those? Because I think when you like whenever you ask me about the
Yeah,
reagents,
yes, yes, yes. You
yeah.
need to revise all the thing daily on the basis of daily. Let's suppose we are studying about alcohol, so you need to revise alcohol for each day up to when we are not, completed that part. I'm asking the
Okay.
part when like up to when it's going on. So
Man, I'm confused now. So we're done with alcohol, right? Or what or
yeah,
no?
we are done with alcohol in next class.
In next class.
Yeah.
So all of the reactions, like the hydration, what is it called? What is the other one? Hydroboration, oxidation, oxymercuration,
Mhm.
oxymercuration, demercuration. Will you test me again on those? Because I've noticed you keep testing me on it, so that's what I was like asking. You know?
Yeah. Yes, I'm